Next example here, example 2, we have a sphere and its radius was measured to be 15 centimeters. If the uncertainty in measurement of the radius is at most 5 millimeters, what is the estimated uncertainty in the sphere's volume? Okay, so another way, some other language we can use is a lot of times we think of dx or delta x as a uncertainty or an error in our measurement or an error in our input variable. So if we consider the volume of a sphere to be a function of the sphere's radius, which it is, the function or the formula for a sphere's radius is 4/3 pi r cubed, or 4 pi over 3 r cubed. So then, effectively, what this theorem up here is saying is this quantity right here, we call this the differential of f. So this is the estimated change in f. This is, of course, the actual change in f. And this right here is our change in, let's just call this our change or uncertainty in x. So here we're saying that the uncertainty in our measurement of the radius is at most 5 millimeters. So we can go ahead and convert everything into millimeters here. So let's just say this 15 centimeters is 150 millimeters. Okay, now it's all in the right unit. It's all in the same units. So what we want to know is, effectively, if we were to mismeasure the radius, incorrectly measure it due to this inherent error of at most 5 millimeters, how could that affect the volume of the sphere? So in other words, approximately, what is the error, what is the uncertainty in the sphere's volume? So the difference in volume, this is approximately equal to the differential based on what we have above. All I'm really doing is taking this theorem above, and instead of delta f approximately equal to df, our name of the function is v, so we have delta v is approximately dv. And we know that the differential dv is v prime of r times dr. So v prime of r is 4 pi r squared and dr. So what we want to know here is, what is this approximately equal to when we've already measured it to be 150 millimeters or 15 centimeters. So if we actually do this at that precise value, so this would be at r is 150 millimeters. Then we're going to get 4 pi 150 squared times our dr, which is 5 millimeters. So this is about 450,000 pi cubic millimeters. And now whenever we're doing this chain of equality, right, we're starting here at this line and we go all the way down, you have to take the weakest form of equality, which is this. So really, in summary, we would say that the change in volume, the uncertainty in the volume, is approximately that much. Which seems like a lot, but when you think of it as how units scale from single millimeters to square millimeters to cubic millimeters, this is actually a reasonable answer.